everyone. I am Dr. Anubha Gupta from ABES Engineering College, Ghaziabad. Today I am going to discuss quantum mechanics part 3. In my previous lecture, I discussed about the Compton effect. In this lecture, I will discuss numerical based on black body and Compton shift, de Broglie concept of matter waves and its base numerical, phase velocity and group velocity. Calculate the energy of an oscillator of frequency 5.3 into 10 is the power 12 second at 500 Kelvin, treating it as a classical oscillator and Planck oscillator. So first of all, calculate the energy of oscillator when it is considered as classical oscillator. Classical oscillator energy is given as E is equal to kT. K is the Boltzmann constant, which is given in this question, but you should remember it. Minus 23, temperature given in Kelvin. If it isn't given in centigrade, we will convert it into Kelvin. It is a 500. So answer of E after calculation become, it is a 6.9 into 10 this is the power minus 21 joule. This is the energy of classical oscillator. Now for energy of the Planck oscillator, formula is h nu upon e raised to the power h nu upon kt minus 1. First of all, calculate the h nu by kt, where h is 6.62 into 10 this is the power minus 34. Nu is the frequency and the frequency is 5.3 into 10 this is the power 12. Kt we already calculate 6.9 into 10 this is the power 21. So after calculating it, I will get 0.505. Put this value here. H nu 6.6 into 10 this is the power minus 34. Means we are going to calculate E. Nu is the 5.3 into 10 this is the power 12. This is the H nu upon. E raised to the power H nu by KT value is, so exponential power is 0.505 minus 1. 6.6 into 10 this is the power minus 34 into 5.3 into 10 this is the power 12 divided by exponential of 0.505. Exponential of 1.65 minus 1. And the answer become 5.38 into 10 this is the power minus 21 joule. This is the energy by Planck oscillator. And energy by the classical oscillator is 6.9 and this is the 5.38. Now second question is based on Compton effect. X-ray photon is found to have its wavelength double on being scattered through 90 degree. Find the wavelength and energy of the incident photon. We know the formula lambda dash minus lambda is equal to 0.0242 1 minus cos theta. Theta is the angle of scattering of photon and lambda dash is the wavelength of scattered photon. So scattered photon is 2 lambda. I will put here 2 lambda minus lambda 0.0242 1 minus cos 90 degree. Angle of scattering given as theta 90 degree. After solving, we'll get minus 242 angstrom is the wavelength of incident photon and the energy E is equal to hc by lambda. We know the h 6.6 into 10 is the power minus 34. C is 3 into 10 is the power 8 and lambda already calculated for the incident photon. It is a 0.0242. Solve it. 10 into 10 is the power minus 14 joule. This is the energy of the incident photon, 8.10. It is a 8.10. Second question based on the Compton effect. In a Compton scattering experiment, X-ray of wavelength, it means it is given the wavelength of X-ray of wavelength 0.015. It is lambda, not the scattered wavelength is not written. And the theta is 60 degree. Find the wavelength of scattered radiation, means lambda dash minus lambda is equal to 0.0242, 1 minus cos 60 degree. Lambda dash, lambda is given 0.015, 0.0242, 1 minus 1 by 2 cos 60 value, and lambda dash become it is a 0.015 plus 0.0121, and it become lambda dash become 0.027 angstrom. Wavelength of the scattered photon is 0.027 angstrom. This is the second question. Now I am going to discuss de Broglie concept of matter wave. In 1924, de Broglie put a very bold suggestion that, like radiation, matter also has a dual nature. Also has dual nature. So matter like electron and photon have wave-like property in addition to the particle property. Means this is the particle property of the electron, which has the momentum P, energy E, mass. And when this microscopic particle is moving, it have the wave-like property also. It have a wave-like property also, which has the wavelength lambda, frequency, and the wave-like property and the particle property are related by a formula which is called de Broglie wavelength formula. Lambda is equal to h by p. It shows that like a radiation, matter also has a dual nature. The wavelength which is related to the particle is called de Broglie wavelength. De Broglie wavelength. Now the different formula for the de Broglie wavelength. Main formula is lambda is equal to h by p, where lambda is the de Broglie wavelength of the wave which is associated with the matter, and the p is the momentum of the particle, which can be written as mv. M is the mass of the microscopic particle. Mass of microscopic particle, which is moving with the velocity v, and lambda is the de Broglie wavelength of the matter wave. Lambda is called wavelength of matter wave. We'll derive different formula if particle has kinetic energy. Kinetic energy E. Then the formula become lambda is equal to h upon m, 2m into kinetic energy. Because kinetic energy is equal to p square by 2m, and p can be written as 2m into kinetic energy. So in place of p, we can put 2m into kinetic. This is the second formula for the de Broglie wavelength when the kinetic energy is given. If particle is moving, and with velocity v under a potential v, under a potential v, then its kinetic energy is given as qv. If the particle of charge q is moving under a potential, under potential v, then kinetic energy is qv. So associated de Broglie wavelength is h upon 2m. In place of kinetic energy, we'll put qv. If charge particle is electron, then the charge is 1.6 into 10 to the power minus 16, minus 19, and the mass is 9.1 into 10 to the minus 31 kg. So after putting this value 6.6 into 10 to the power minus 34 twice, mass of the electron is 9.1 into 10 to the power 31, and the charge is 1.6 into 10 to the power minus 19 coulomb, and the V volt, it can be different. It become 12.27 upon under root V. This is the de Broglie wavelength formula for the electron only. And if particle is moving is moving due to the temperature T, then its energy is become kT, and the associated de Broglie wavelength is become 3 mkt. So these are the four formulas. First is this, second is in terms of kinetic energy, third is in terms of kinetic energy, and the four is in terms of temperature. And this one is the special case of third one, and this is for electron, 12.27 upon under root V. V is potential under which the electron is moving. Let us do some numerical based on the de Broglie wavelength. A proton is moving with the speed of 2 into 10 to the power 8 meter per second. Find the wavelength of wave associated with it. We know the formula lambda is equal to h upon mv. But here mass is relativistic. So we will take mass as a m naught upon under root 1 minus v square by c square, where rest mass of the proton is 1.6 into 10 to the power minus 27, 1.67 upon under root 1 minus velocity is 2 into 10 to the power 8. So the square is 10 to the power 16 upon c square. It is a 9 into 10 to the power 16. Calculate the mass from this and calculate this value, and after calculating this value, put the mass in a main formula. Becomes 2.24 into 10 to the power minus 27 kg. Put this value in this formula. Lambda is equal to 6.6 into 10 to the power minus 34. In place of mass is a relativistic mass. 2.24 into 10 to the power minus 27, and the velocity is 2 into 10 to the power 8. This de Broglie wavelength associated with the proton is 1.47 into 10 to the power minus 15 angstrom, is in 15 meter. Answer. Next topic is phase velocity. Velocity of a single monochromatic wave in a medium is called phase velocity. We know that the wave can be represented by the equation y is equal to a sine kx minus omega t. This kx minus omega t is called the phase of a wave. Kx minus omega t is a constant for a wave, which is called the phase. And I can write as after differentiating that dx by dt is equal to the velocity, which is equal to omega by k, and it is equal to dx by dt. So the wave velocity or the phase velocity is called the omega by k. This Vp is omega is the angular frequency and the k is the Boltzmann constant. What do you mean by group velocity? Wave packet obtained by superposition of wave. The n number of waves, the velocity with which the wave packet is transmitted is called group velocity. So first of all, wave packet form, which is the superposition of n number of waves, and when the velocity with which this wave packet is this is the wave packet which has the superposition of n number of waves, and the velocity of the wave packet is called the group velocity, which is equal to d omega by dk. Now I will discuss the relation between group velocity and phase velocity. We know that phase velocity is omega by k and the group velocity is d omega by dk. I am going to establish the relation between phase and group velocity. Omega is equal to Vp into k. So differentiate d omega with respect to k, d omega by dk, because I want to make a one term as a group velocity. Vp plus k dvp by dk. Now I'm going to divide this equation by a d lambda. This is a d lambda, and multiply and divide by the d lambda. It is a velocity dvp by d, and I'm going to divide it by d lambda divide and d lambda multiply. Y d omega by dk is equal to Vp plus k dvp by d lambda and d lambda by dk. We know that k is equal to 2 pi by lambda and dk is equal to minus 2 pi by lambda square into d lambda. Differentiate this k with respect to the lambda, it become dk by d lambda become minus 2 pi by lambda square into d lambda. So this equation become d omega by dk Vp plus k is the 2 pi by lambda dvp by d lambda, and in place of d lambda by dk, this is the d lambda by dk, it become minus lambda square upon 2 pi. I'm going to put this value here, minus lambda square upon 2 pi. 2 pi is cancel out, this cancel out. It become d omega by dk Vp minus lambda dvp by d lambda. D omega by dk is equal to Vp minus lambda dvp by d lambda. And I can write d omega by dk as a Vg Vp minus lambda dvp by d lambda. This is the relation between Vg and Vp for dispersive medium. In a dispersive medium, velocity depend on the lambda. And for non-dispersive medium, dvp by d lambda is equal to 0. Velocity is not depending on the lambda, and it become group velocity become phase velocity. This is the relation between group velocity and phase velocity. So in this lecture, I covered about the numerical of the black body and the Compton effect, phase velocity, group velocity, and the relation between the phase velocity and group velocity, and the some numericals on the de Broglie hypothesis also.